In this video, we will study about VM placement and VM migration. So, what is placement? It is about finding out a suitable server in a data center. Let's say there is a very big data center which has lot of servers, right? I have one requirement. I have to choose a most suitable server. So, how do we choose a suitable server in a data center? That is VM placement. So, placing, where do I place the new virtual machine? I have to choose a server for that, right? So, that is VM placement. Let us understand what is VM placement. Virtual machine placement in cloud computing is a strategic process of selecting the most suitable physical host machine for virtual machine, suitable machine for virtual machine, right? You have to, from the available pool of servers, I have to choose a most suitable physical host machine, physical server, so that I can place or I can install my virtual machine, I can create my virtual machine. Why I have to choose a suitable one? So that I can maximize the resource utilization, ensure high performance and minimize the energy consumption. So, I have to see my requirement is of this much GB RAM, this much CPU cycle, all that I have to check in that server, so that the virtual machine which I am creating is nicely working, right. So, what all things it includes? It includes mapping virtual resource intensive workloads onto physical data center, right, onto physical data center infrastructure based on the requirements like CPU, RAM and network capacity. We have to map, right. So, whatever workload will my virtual machine will have to take care of, that I will match it with the server's infrastructure, right. So, my requirement could be in terms of CPU, RAM and network capacity. Okay. So, the goal of virtual machine placement can include energy efficiency, load balancing and reducing parameters like cost, SLA, service level agreement violations, network latency, congestion and service failure, right. So, when I am placing, when I am choosing a virtual machine, when I am choosing a server to place my virtual machine, I have to keep all these parameters in mind, right. So, there are lot of servers available, right. I have to choose, I have to create virtual machines and I have to place these virtual machines into these servers. So, I have to follow some strategy, I have to take care of energy, load balancing, SLA violations, network latency, congestion, all those parameters I should keep in mind and choose a physical server. That is about VM placement. So, there are basically two types of VM placement schemes. Okay. So, one is static VM placement, second is dynamic VM placement. So, what is this static and what is this dynamic VM placement? Let us see. So, in static VM placement, right, the mapping of virtual machine is fixed throughout the lifetime. Once you choose a physical server to host your virtual machine, that virtual machine and the relation with its host is fixed always. You cannot change that virtual machine's host. Okay. It is the mapping in which the mapping of the virtual machine is fixed throughout the lifetime of the virtual machine and it will not be recomputed for a long period of time. So, once you create a virtual machine, you will not be changing its host, you will not shift it from one server to the other server, whatever is the problem in that, right. Whereas, in dynamic VM placement, right, I can change it depending on the load. Let us say I choose physical server 1, for the virtual machine. When the load increases, I can shift it to physical server 2. I can move it from one server to the other server. That is static and dynamic placement. Okay. So, once you decide a virtual machine, once you decide a host, that remains same for the lifetime of the virtual machine. Whereas, in dynamic, it can change depending on the load. In dynamic VM placement, we have two cases. We have two types, right. So, one is reactive virtual machine placement, proactive virtual machine placement. Reactive means only when some issue comes, I will change my server. Proactive means before any problem comes, if I see some condition, I am expecting some error in that, immediately I will change the server. Okay. So, reactive means you are reacting after some issue is coming. What problem can come? Some problem like the performance, maintenance, power or load issues, right. If there are some challenges, then I will move it. In proactive, if I see something is about to come, immediately I will react and I will try to move the virtual machine from one server to the other server, right. This is about VM placement. There are two schemes, static and dynamic. In dynamic, there are two algorithms. One is reactive, other is proactive, right. And the next most interesting concept is, and very important, is virtual machine migration. Okay, if one virtual machine, some failure happens, see, in a server, in one particular server, I am having so many virtual machines. Right. So, if this virtual machine, there is a problem, right, I have to migrate it from this server, this physical server PS1 to another PS2. I have to migrate it to another one, because I am experiencing some problem in this virtual machine, in this physical server. So, I have to move it to the next one. So, how do we migrate a virtual machine from one host to the other host? That is what we are going to talk about, right. So, virtual machine is a process of moving a virtual machine, virtual migration is a process of moving a virtual machine, right, from one physical host, right, or storage location or data center to another. We are moving it from one host or one storage location or one data center to the another, designed to optimize the resources, enable maintenance and balance the workloads. If in the physical server in which I had my virtual machine 1, if it is having some problem, or this physical server 1 is having limited capability, limited resources, I have to move it to physical server 2. I have to move it to this, right. It can be performed as hot or cold. It can be performed as hot migration or cold migration. What is hot migration? When the virtual machine is running, some application is being running, some task is being performed in that, then you are migrating it. Cold migration means you stop that virtual machine and you then move it to the another server. In hot, you don't stop the virtual machine. Without knowing the user that you are changing its physical infrastructure, the underlying physical or the host machine, you will do the migration. That is hot or live or running migration. When the application is running, when the virtual machine is running, without knowing the user, you are migrating it. That is hot. Whereas in cold, you will stop that virtual machine, stop everything, shift it to the new place and then start again from beginning. That is cold migration, right. So, there are two important differences between these two methods, between live migration and the cold migration, right. In live migration, needs a shared storage. It needs a shared storage. The underlying between physical server 1 and 2 should have some common storage. Only then you can do. But cold migration does not need that. Okay, cold migration does not need that. You should have one shared storage in the hot migration. Okay, because when there is because we are doing the migration during runtime, no. So, that memory transfer should happen from one server to the other server. There should be a common shared storage between those servers. Only then it is possible, right. Whereas, another difference between these two is that for live migration of a virtual machine between two different hosts, there should be a certain CPU compatibility check. You have to check whether the CPU is compatible of this virtual machine from this physical server 1 to the physical server 2. Right. Whereas in cold migration, we don't need to check this, because you are stopping it here, going and starting it there, it will automatically happen without any problem, right. So, the differences between live migration and hot migration is that in live migration, I should have a shared storage for virtual machines in the server's pool, but cold migration does not need a shared storage. And the second difference, the live migration, when you are moving from one host to the other host, we need to check, we need to worry about the CPU compatibility. In cold migration, we don't check that, right. This is about VM migration. Let us see and understand what is hot migration and what is cold migration, right. What is the process of hot migration? Okay. So, this is a process of hot migration. It has steps from stage 0 to stage 5, total 6 stages. Let us understand what is this. At each stage, what we try to do. Okay. So, stage 0, what is the first step? In stage 0, it means pre-migration, before actually migrating it. Okay, you have an already active virtual machine running. That's what, no, we already have a virtual machine running on host A. Then alternate physical host may be pre-selected for migration. Before migrating, you have to look for another host B. We look for that. And block devices mirrored and free resources maintained. You have to make sure that the CPU, the RAM, whatever you want are blocked in this host 2. As per your virtual machine's requirement, you have to reserve them in the host B. Then stage 1, reservation. Stage 2 is called reservation. Initialize a container on the target host. It means you have to reserve a what we say container. Okay, that we have to do in the stage 2. What is this reservation? A container is created on host B. Okay, and space for CPU, RAM, everything is reserved. That is what reservation means. You are creating a container and you are reserving the space and all the details. Then stage 2, iterative copy. Stage 2 is iterative copy. Enable shadow paging, copy dirty pages in the successive rounds. What is this? In stage 2, pre-iterative copy, virtual machine is still running on host A. Okay, it is working fine still on host A, but the memory pages are being copied iteratively from host A to host B. Okay, memory pages in the host A is slowly shifted to host B one after the other. If some memory change is happening, they are again copied second time. That's why it is iteration, right? See, it is self is there. If some pages have not been copied or some pages have been copied, there is some change in that, then you will do that again. Repeated rounds you will be trying to move that. And then stage 3 is stop and copy. You suspend virtual machine on host A, you generate the ARP to direct the traffic from host B to host B and synchronize all remaining virtual machines to host B. What is this? What we do here, the virtual machine is briefly paused on host A, the last remaining memory and the CPU state is copied into host B and the network traffic is diverted to host B. Okay, there is a very small downtime. You see, downtime is there here. Though we are calling it as hot or live migration, there is a very millisecond or second downtime is there. Why? Because the remaining pages of the virtual machine or the host A are also copied back to host B. Okay, and the stage 4 is commitment. Commitment means the host A is deleted, all the resources of host A are released. Okay, and finally the stage 5 is activation. Stage 5 is activation. So what we do here, the virtual machine B, that virtual machine on host B starts running. It gets connected to devices and network and users continue working as it is. Okay, so without knowing anything, the normal operation is resumed in host B. This is live migration. The downtime is very less. You are copying all the memory pages from host A to host B. Once you are pausing it, if there is some change, that also you are copying it. Okay, this is the algorithm or the process of hot migration, hot virtual machine migration. Stage 0, it is pre-migration, then stage 1 reservation, stage 2 iterative pre-copy, stage 3 stop and copy, stage 4 commitment and stage 5 activation. This is the steps in virtual machine hot migration, right? Why there is a overhead here? Sorry, why there is an overhead here during copying? See, sometimes some pages which you have copied already, some change happened later. So you have to again recopy it multiple times. That's a little overhead. Why here there is a downtime here? Sorry, there is a small downtime here, right? In this there is a small downtime. Sorry, there is a downtime here. Why is this downtime? Because you are slightly for a few seconds you are pausing the host A and then you are routing the traffic to host B, right? Let's see the next migration process, that is cold migration. So in hot migration we understood that we are having very little downtime and we are quickly moving it without knowing the users of that virtual machine know that some movement is being happening. Okay, the second one is the cold migration process, right? the cold migration process. What is this cold migration? Okay, let's understand that. So in cold migration, it is called as power off migration. You are offing the power and then you are migrating it. So one virtual machine is stopped completely, then all the data is shifted, and then the virtual machine network is routed, and then you are starting it in the another host. Okay, so the migration of powered off virtual machine. You are migrating in power off virtual machine. Okay, with cold migration you have the option. With cold migration you have the option of moving the associated disk from one data store to another. Okay, and virtual machines are not required to be on a shared storage. They need not be in a shared storage. They can be in any other data center also, any other server also, right? Cold migration process is simple, and it can be done using these following steps. Okay, since it is very simple, you stop it here, move everything, start it there. 3 steps. Same thing is applicable even in this. See, the configuration files including the RAM, the log files, as well as the disks of the virtual machine. Okay, everything are moved from the source to destination host associated with the storage area. So you are moving from source to the destination. All those log files, RAM file, BIOS settings, everything, right? The virtual machine is registered with a new host. The virtual machine is registered with a new host, that is in the new server, right? After the migration is completed, the old version of the virtual machine is deleted from the source. Simple as that. Okay, so this is about the cold migration process. So we have seen about hot migration and cold migration. So this is about the virtual machine placement and virtual machine migration concept. Thank you.